sample spaces, and we're looking at sample spaces. Right, so a table is used when there are two stages in a probability experiment. Now, guys, most of the time we've done once, now we're doing two. The outcome of one stage are listed across the top, and the other stage is listed along the side. The table then gets filled in with the combinations of the two trials. So let's have a look. So say we're doing tossing a coin, so head and tails, rolling a die, 1, 2, 3, 4, 5, 6. So we go the die outcomes and we plot them along there, coin outcomes, plot them along there, and then just do your combination. So head and 1, and make sure we put a comma between so you can see, and then head and 2, head and 3, head and 4, or tails and 1, tails and 2. Okay, pretty self-explanatory. So the size of the sample space is determined by the product, so that's multiplying, of the number of outcomes in each stage. So a dice has got 6 outcomes, 1, 2, 3, 4, 5, 6, and a coin has got 2. So you go 6 times 2, and you get 12. And if we look in our previous table, you'll see there's 12 actual outcomes as well, so it's 12 outcomes. So Nicole is packing for an overseas holiday. She plans on taking 3 shirts that are blue, white, and black, 2 pairs of trousers that are tan and black. So if each combination of the shirt and trousers is an outcome, calculate the size of the sample space. So here we've got 3, and there we've got 2. So 3 times 2, 6. Cool. B says, use a table to construct a sample space of the different outfit combinations. So we've got 3 shirts. So we're going to go blue, white, and black and label that shirts. And then we're going to go trousers, tan and black, and then you're going to go tan and blue. Remember to put your comma in, white and tan. Okay. A systematic list, so that's something else, is constructed by systematically listing all the outcomes of the first stage with the outcomes of the second stage. To me, it's the table without the lines. So a coin is tossed and a spinner is spun with the outcomes A, B, C. So you've got head and tails, and you've got A, B, C. So your sample space is going to be, let me just move this out of the way, head A, head B, head C, tail A, tail B, tail C. Remember, just to space them out and put commas in so it's clear for people to see, okay, for the answers. You can put them underneath each other if that makes it easier for you. So a pizza restaurant offers 2 types of base, thin or thick, and 2 types of barbecue or tomato. They can be ordered in any combination. Calculate the size of the sample space. So first of all, we've got 2 there, and we've got 2 there. So we go 2 times 2, we get 4. And then B says, make a systematic list. So you're going to go thin barbecue, thick barbecue, thin tomato, thick tomato. Okay, there we go. Thin barbecue, and you see that's a colon, a semicolon. So that's differentiating it from thin tomato, thick, thin, and then tomato, thick, and then barbecue. So make sure you put your semicolons, or just put them underneath each other so we know what the difference is. Right. So if you're selecting 2 items from a list, repeats can't happen. So for example, Colby, Charlotte, Bridget, and Tom nominate for the school tennis team. Only 2 positions are available. The possible team combinations would be, so you've got their names there, and the second person select, you've got all their names there. Obviously, Colby and Colby can't be done, so you put an X. Charlotte and Charlotte, Bridget and Bridget, Tom and Tom. Oh, my goodness, what happened there? Sorry, let me go back. Right. And then you can put them in. So Colby and Charlotte, that way. The first person and the second person. Just remember to put your commas in. So Patrick is in the gym and wants to add weights to the bench to increase his load. He can choose from a 2 kilo, a 5 kilo, a 10 kilo, or a 20 kilo weight. Only enough space to add 2 weights to his machine, and only one of each of the weights to choose from. So let's pretend there's only one of each. So calculate the sample space. So first of all, what you've got to think of is there are 1, 2, 3, 4 weights. Okay, but there can't be 4 times 4 because once a weight has been selected, it can't be selected again. You can't take, there's only one of the 20 kilos, so you can't take 2 20 kilos. So it only has 3 possible outcomes. So therefore, you're going to go at 4 times 3 equals 12. So always keep that in mind. Then B says use the table. So you see how 2 and 2 gets crossed, 5 and 5 gets crossed, 10 and 10 gets crossed, and then you just do your combinations, 2 and 5, 2 and 10, 2 and 20. All right, let's see if we can do this.